So we can further classify matter in terms of its chemical composition, and this is where things do get a little bit tricky for some people because sometimes it's very difficult to figure out, whether these things are pure substances, mixtures. Then we break that down even further into elements, compounds, homogeneous mixtures, or heterogeneous mixtures. And so we're going to start off with actually the easier of the two here. And the first one here is a pure substance, and that is a single kind of matter that cannot be separated into any other kinds of matter by physical means. It has a definite and constant composition. Another term I like to refer to it as is one substance, okay? And then we're going to break that down even further into elements and compounds. Pure substances, once again, are either elements or compounds. Elements are substances that cannot be broken down into purer or simpler substances. So anything that's alone on the periodic table of elements. So hopefully you have a periodic table with you. I've provided you with quite a few already. Anything that is just listed as an element on that periodic table, anything that's just listed as an element is going to go in that elements category. Okay? Now, you may have something that has a combination of elements. That would be a compound, though, rather than an element in and of itself. Compounds, however, are made up of two or more elements that are chemically bonded together. Now, they can be separated, but only by chemical means. So for example, here we're going to talk about water again. When you heat water, it does not change its chemical composition, right? It just changes its state of matter into a gas. Or if you're melting it, it's just changing it into a liquid. So again, I go by the term substance. If I were to give you some water and ask you how many substances are in here, you would just tell me one. There's just water. Or if I were to just give you a vat of ammonia, first off, it smelled really bad, but you would just tell me this has ammonia in it. There's just one substance. And then you just kind of have to break that down into, okay, well, does that substance contain just one element or does it contain two or more different elements? Okay? Same thing with sodium chloride. If I handed you some table salt, you would just tell me that there's one substance in here, salt. The Na and Cl are chemically bonded together. Sometimes this is also best observed through what are called particle level diagrams, which is really breaking it down and zooming in on what does this really look like from a particle perspective. We'll dive into that a little bit later on. Okay, now mixtures are two or more substances that can be separated by physical means, and so that's the difference here. So think of a salt and sand mixture. First off, two or more substances, right? Salt and sand are independent of one another. I could conceivably separate all of these things, right? I could put the mixture in some water, and the salt would dissolve and the sand won't. And then I could evaporate the water and obtain the salt. So I can separate the salt and the sand by physical means. I didn't have to do anything fancy chemically. I just poured the mixture in water and the sand didn't dissolve, so I can extrapolate the sand through filtration or pouring off. Decanting is the word that we use in chemistry, but we can pour the water off of the top and then just heat the water. When the water evaporates, the salt would be left behind. So there are two or more substances that are found in mixtures that are not chemically bonded together. You have the ability to separate them by physical means. I'm not talking about chemical changes. I'm talking about using physical ways to be able to go through and change or separate them. Now, mixtures can be classified as either homogeneous or heterogeneous, and it just depends on the uniformity of the material. So homogeneous mixtures are uniform throughout one phase. So for example, milk. Milk contains water, it contains whey, it contains fat, it contains casings, but you can't tell those individual components apart from one another. It is considered in one phase, and so as a result, that is considered a homogeneous mixture. Same as sugar water. When you mix sugar and water, the sugar dissolves, and so you cannot individually determine the sugar from the water from each other. And so again, that is a homogeneous mixture. It is uniform throughout. We have other mixture that's called heterogeneous. It is non-uniform throughout, so more than one phase. So good examples of these would be pizza, Italian salad dressing, chocolate chip cookies. You can discern the individual components that are found in that. I can see the chocolate chips in the chocolate chip cookie. I can visually discern the individual components of a pizza or of Italian salad dressing because it does not mix. So if you figured out that you've got a mixture, you just have to figure out, is it uniform in composition or is it non-uniform in composition? And then you can determine whether it is homogeneous or heterogeneous. So again, I'd like to mention the flowcharts that I'm using here. You have matter. Does it have constant properties and composition? If it's yes, it's a pure substance. And then you can ask yourself, can it be simplified chemically? It's an element if it can't, and it's a compound if it can. Constant properties and composition, if the answer is no, it's made up of two or more substances then it is a mixture. And is it uniform throughout? Then it is heterogeneous or homogeneous. So again, this can be tricky. This is, again, we practice. That's the whole point of all of this, is to practice so that way we can get better. All right? So when I look at things on a particle level, I notice here I have an element on the left-hand side. Let's just look at the pure substances for now. We have an element there, and notice that every single atom is exactly the same. And that's the case with elements on the periodic table. You're going to find that elements on the periodic table all have the same, roughly the same composition. It's the number of protons that are the same. We'll discuss ions and isotopes later on. But elements are going to be very similar, and so that's why they're all colored green. But you notice a compound, notice how they're all touching each other, the green and the purple dots. That's indicative of a compound because you have two or more elements that are chemically bonded together. If two materials are touching one another, they're considered to be bonded. But take a look at the mixtures down there. Okay, so notice your homogeneous mixture, you have two or more substances, but notice that they're not bonded together, right? The green dots are not touching the purple dots, and notice that they are scattered throughout fairly uniformly. And so that is a homogeneous mixture. And then on the right-hand side, notice that there are clumps of the purple material interspersed throughout the green material. So I would say that that is heterogeneous because that is not a uniform composition. So again, let's take a look and see if we can decipher these four things just based off of this information here. Now, again, this is a little bit tricky. Take your time and think about, okay, if it's one substance or two substances, and then based off of that information, would it be a pure substance or would it be a mixture? And then break it down even further and figure out, is it an element? Is it a compound? Is it homogeneous? Is it heterogeneous? All right, take a moment with that and we will come back and answer those questions. All right, so the very first one here says one substance present. If one substance is present, that immediately takes me to the side of pure substances. And then I break that down even further. It says three elements that are present. Well, then that's going to end up being a compound, okay? Because there's not just one element. If it said one substance and one element, then it would be an element. For B here, it says two substances present in one phase that is present. Okay, so two substances present. That tells me that I have a mixture. Right? There are two or more different independent substances that are present in this material. One phase present indicates that it is uniform, so I'm going to say that this is a homogeneous mixture. If it said that there were two substances present and two phases, then that would be a heterogeneous mixture because they've clearly separated. That's why you see two phases. For C here, it says one substance present, one phase that cannot be broken down chemically. So one substance, again, puts me on the side of pure substances. One phase cannot be broken down chemically. It is an element. And then we have two elements present, so two elements, but the composition is variable. All right, that does not mean that they are chemically bonded together. In fact, it means quite the opposite. They are separate from one another. So that tells me that this is a heterogeneous mixture, okay? It's tricky. It's tricky. But again, take your time, really evaluate the situation and think about, okay, what do I have? Do I have one substance? Do I have two substances? Are they bonded? Are they not bonded? Is the composition uniform? Is the composition variable? It's much easier, again, to look at these things on a particle diagram to figure those out or given actual materials, but I did want to use some information from the textbook in order to kind of break things down just in case your chemistry class goes through things this way.